So to get us started on our study of scale factors and similar shapes, there's a bunch of vocabulary here that I'm not going to sit here and read over, but instead I'm going to recommend that you copy down into your notebook after hitting pause on the video. I'm also going to remind you that the act of copying it is one of the ways that your brain processes and learns information, so I'm going to encourage you to actually write it down. Okay, so I'm assuming that if you got here, you've already copied down all of the information from that first page. And so we're going to talk a little bit about what we mean when we're talking about corresponding sides and corresponding angles. And it's a relatively straightforward concept. We just have to be careful not to take it for granted. So here, if we talk about corresponding sides are just the sides that are both the related sides in each shape. So for example, AC is the smallest side in this triangle, so we need to find the smallest side in the other triangle. And so AC here corresponds to DF. So I'm just going to write that down. So AC corresponds to DF. Okay, so taking a look at another side, I could look at the longest side, maybe, of each triangle. So the longest side is always the hypotenuse. And so if I look at this longest side, BC is corresponding to EF. And so those are the two corresponding sides. BC corresponds to EF. And then that leaves this sort of second longest or second shortest side, however you want to consider it. And that is AB, and it corresponds to DE. And so those are the next two corresponding sides. So what was that? AB corresponds to DE. So it's just which sides kind of belong together. Same thing with angles. We've got corresponding angles and they work pretty much the same way. So you just take a look at what angle is in the same position, if you will, as the angle in the other triangle. So here we've got an angle BAC. We always name it with the vertex or the corner in the middle, and that corresponds to angle DEF. So angle BAC corresponds to angle EDF. I'm not sure if that's what I said before, but that is what it is, EDF. And then let's take a look at another angle here. How about this angle at C, so angle ACB, and we'll mark that with just one arc. And so ACB corresponds to DFE. Angle ACB corresponds to angle DFE. And last but not least, let's find another color. Ooh, how about purple? So this angle up at the top, which I'll mark with two arcs, it's a little tricky to see. So that's ABC, so triangle ABC. Corresponds, that's a B, corresponds to DEF, angle DEF. So that's all we mean by corresponding angles. And it's nice and easy as long as the shapes are done in the sort of same orientation. We'll look at some in a minute where I twist them around a little bit and life becomes a little bit more complicated, because that's where math becomes fun. Okay, so once we've learned how to sort of think about these sides as relating to one another, we can start to think about how the small triangle grows to become the larger triangle. So let's first begin here by identifying the corresponding sides. So here, 3 looks like the shortest side of this triangle, so I'm going to look at this triangle, I'm going to find its shortest side, and that's the 9. So the 3 corresponds to the 9. And that means that this unknown piece here, this x, corresponds to this longest side, this hypotenuse here. Well, to this longest side, x, and to this longest side, 18. So I'm going to use this thought to think about how did this smaller triangle scale to become the larger triangle? In other words, what did I do to the side? What do I do to the 3? What did I multiply the 3 by to give me 9? Well, so going from the smaller triangle to the larger triangle, 3 times 3 is 9. So this has a scale factor from the small triangle, from small to big of 3. Okay, so how can I now use that information that there's this scale factor here? This is I multiply by 3 to go from one side to the other side. How can I use that though to find out the x, because I don't have the smaller value, I only have the bigger value? Well, if I'm multiplying by 3 to go from the smaller to the larger, then I'm doing the inverse of multiplying by 3, which is multiplying by 1/3. Now, some of you are going to say, but wait, I was going to say divide by 3. Well, multiplying by 1/3 is the same as dividing by 3. So we can think of going backwards. We've got 18 times something, and I'm going to write that as 1/3, is going to give me whatever this x is. So the scale factor going back is the inverse, right, of the scale factor coming the first way. So in other words, 18 times 1/3. Well, I'm going to write that as 18 over 1, and I'm going to cross cancel because I love cross canceling, and so that is going to be 6 is equal to my x. So x here is 6, and I don't know the units here, so I'm just going to say it is 6 units long. And I did that by using the inverse of the scale factor, multiplying to come here, dividing or multiplying by the reciprocal to go back. So let's take a look at one where maybe it's not super obvious which sides are corresponding. So here's one, for example. So they're not completely lined up like the other ones, so I just need to take a second here before I get started and just identify. This is the short side, this is the short side, and this is the long side, and it corresponds to the long side. Sometimes if these get more complicated, it will make sense to actually draw the shape